is the gas chromatograph, GC. Okay? Gas chromatograph. Then this other part, this side, is called the mass spectrometer. Okay? Or mass selective detector. Are we together? Sure. So the way this particular instrument works is that when you have a sample, the sample has to be injected through this particular part here. So this forms what we call the injector. Remember I talked about the injector. Okay. So the sample can be in liquid form or in gas form when it is being injected. Now this particular injector is very hot. I don't know who is a volunteer. Just to tell your people that it is indeed hot. Come and touch it. Do not bend. Don't touch it continuously. Don't touch it. Just touch there. Here. Touch here. How are you feeling?
Very hot.
It's very hot. Okay. Please. Don't go away and say no. We never even tested. Yeah. You can have a feel. So in the presence of three witnesses, we now know that it is hot, isn't it? So why is it hot? The reason why it is hot is that when you are injecting, the sample may be in liquid form. Okay? So when you inject sample here, even if it is in liquid form, in this injector, sample must quickly be converted to a gas. It must be evaporated to a gas. Are you together? That is why it is very hot. Okay? So we've got what is called manual sample injection. We can just come and inject. Or we've got this particular unit. So this particular unit sits here. It's called an auto sampler. Okay? So the auto sampler has is it here? The auto sampler, can you give me that one? There is a syringe there. Not that one? Okay. So the auto sampler, inside here, the auto sampler has a syringe. So this syringe is called the Hamilton syringe, and it can take the maximum of sample 10 microliters, very minute. The 10 microliters is like a dot. Okay? So it doesn't take milliliters of sample. So that is why for forensics, you just need enough sample. You don't need the kilograms of sample for forensics. That's enough. Because when you come here, so this is going to come and pierce that. So inside there is a septum. So you need to regularly change the septum to ensure that the correct septum is used. So this is usually operated automatically. Okay, so you can load many samples, but only one sample at a time. Are we together? Yes. Only one sample at a time. I told you the GCMS, one sample at a time, but the other HPTLC, you can even do 20 samples or 40 samples at a time and run them together. You save time. Okay. Then we have inside here. Okay, maybe the camera can pick. So inside here, this is what we call the oven. Okay, so this is also hot, and it has an insulator. Okay, so this insulator ensures that heat doesn't come to the operator. Heat is used. So this oven has what is called a column. Now that piece of material looks like hair. Okay?
Yes.
Let me show you. Can you give me one of these big boxes? Even that one. Let me see what is in there. Perfect. Okay. So again, we'll go by witnesses. This is what is called a column. Okay? Can you see how thin it is? Very thin, huh? Handle it carefully, it breaks. So this thin thing has a hole inside it. It has a hole inside. This is where sample comes in and starts moving until it comes out. Okay? So it's very thin. So let's see what are the dimensions of this. Okay? So this type of column, its trade name is Zebron. Okay? So the Zebron column, columns always come with the dimensions. Let me check. They usually come with dimensions. If not, yeah. So this Zebron column, okay, you can pick. So you can see ID means the internal diameter. So inside this little thing, there is a hole that is about 0.25 millimeters. This is very small. Okay, very small. Okay, not 1 millimeter, but 0 point. Okay, before you move that particular mark on the graduation mark, you have that particular hole. Okay, then this is about 10 meters. It's about 10 meters. So you can see it's written 10 meters. Okay, so when you stretch this, it will go 10 meters. Now, why is it coiled like this? It is coiled like this to ensure that you increase what we call resolution, because you need to separate materials so that each material comes as an independent signal. Okay, yeah. Some programs are running. Okay. There are these pieces here. Now down. They are white pieces. The papers. Down. Yes. Pull any. Okay. So we have what are called spectra. Okay. So these spectra, you'll be seeing lines. Okay. So this is what is called a GC spectrum. Okay. On top, we call it a GC spectrum. Below here, we call it a mass spectrum. Okay, so the GC spectrum comes like these peaks. So you can see this peak is different, that peak is different, that peak is different. So you need to have a very good column to separate these so that each of these is separate and identified. Then you can take each of these peaks and analyze it using a mass spectrometer. So you have detail number 1, and then you've got detail number 2. So this is more detailed. It gives you more information. What compound it could be, what is its mass. Because all of us are male, Yes. But some are fit, some are fat, some are slender, others are tall, others are thin. But the eye is asking, they are men. So being men is what we just call low resolution. But then when we go to height, no, this is tall, this is short, we start having another type of detail. Are we together? Yeah. This is what this machine does. Okay, so this is made into a coil so that we have very high resolution. If it was made into a short coil, everything is just going to come in one. Are we together? Yeah. Yeah. So when it is running, we've got programs that are, due to time, we might not show you, but because it is finished. That's good. It's finished. Okay. Yeah. So when it is running, you don't open this. It will not even let you open it, because when it is running, it will give an alarm that, hey, I'm working. don't open me. The reason why we opened it is because the run is finished and the lock is off. Otherwise, it has to lock itself. Yeah, and also here you see a light. Then you know it is working. If it's not working, it's off. Okay, so this collects gas chromatography information, and then this collects mass spectrometry information. And the two informations become so rich for forensics. Okay, the nitty-gritty of how this operates, we can send some material to you to read, but overall, it is also coupled to a PC. So you can load your, you can put your sample here and make a program here. You can go home. The machine will just work by itself. It will come and pick. There's a arm here. This is an arm. So this thing comes, it's a robot. It will pick up and loads the sample like here. So it does things automatically. But when you are loading like this, right, like right now one of the students is doing it, you have to be here manually. Are we together? But if you put this auto liquid sampler, ALS, auto liquid sampler, you can go home. You can load so many samples. But remember, it's one sample at a time. Are we together? It's one sample at a time. So we can load material that we suspect to be explosive material here, and then the machine is going to analyze them one by one and then give us a report in terms of the particular readings we have. Okay, so this machine operates under a vacuum. So that pump is 24. So when there is electricity blackout, we have a problem. Okay, we have a problem. Yeah, so this was donated to us through the OPCW. OPCW is the Organization for the Prohibition of Chemical Weapons, for which firefighters are part and parcel of the first responders. To be a firefighter, you need to go through the first responders course. I'm sure Mr. Banda has exposed some of these courses to you. If not, we can go to the OPCW site. It's free. They will sponsor you. They'll give you an air ticket. They'll take you to the Netherlands, put you in a hotel for 3 months. You learn, you come back as a first responder, so that you understand how to do chemical sampling, you understand how to run this machine, etc. Are we together? Sir. Yeah. So that's about the machine. If there are other questions, they can be raised. We can explain.
Thank you, sir.
Sure. Sure. So let's see where you go next. Let me check up with Mr. Lengo.
A question might be raised. What would be the, maybe a fee?
A fee?
Yes.
Oh yeah, that's a good question. Is there a fee attached to analysis here? So we are trying to have an MOU with